Kia ora. This is an introduction to the atomic structure and bonding topic. First thing we're going to look at is the different types of bonding that we're going to be covering in the topic. So here they are in a nutshell: covalent, molecular, ionic, metallic, and covalent network. And we're going to dive into the details of those in more depth. Firstly, covalent molecular. This is between a non-metal and a non-metal. Example here is methane. So what we see a carbon bonded to 4 hydrogen atoms. What's happening here is the electrons are being shared. If we think of the red electrons as being from the hydrogens and the blue electron being from the carbon. So carbon has 4 electrons in its valence shell. Hydrogen has 1 electron in its valence shell. What's happening is carbon is sharing its 4 electrons with these 4 hydrogens, and each hydrogen is sharing 1 electron with the carbon, such that in the end carbon has a full shell of 8 electrons, or at least it's sharing in 8 electrons to fill up its valence shell, and each hydrogen has a share in 2 electrons to fill up its valence shell. So the covalent bond is formed by the sharing of electrons between atoms. And we're going to look at this in more detail. This is just an overview for now. The particles in covalent bonding are molecules. An example, this whole thing here is a molecule. There are strong intramolecular forces within the molecule, so the forces holding these atoms together are strong, but there are weak intermolecular forces. The forces between each molecule are weak. Okay, so this is just, you can see on the periodic table where the nonmetals are. The nonmetals are the ones in green. You may also get some of these yellow ones involved as well, but more commonly the green ones. Ionic bonding occurs between metals and non-metals. So that is between these elements on the left-hand side of the periodic table and these elements on the right-hand side of the periodic table. Not the pink ones; they don't bond because they already have a full valence shell. Ionic bonding happens so if I go back to covalent bonding, what we have here is sharing of electrons. Ionic bonding involves a transfer of electrons. For example, sodium chloride is a great example. What happens is the sodium atom loses an electron. The sodium has 1 electron inside the shell. It loses that electron, and the chlorine gains that electron to form a full outer shell. So then both sodium and chlorine have full outer shells. They're now both ions. Sodium is positively charged. We could think of that as the purple ones, and the chloride is negatively charged. That would be the green ones. And what happens is those ions, there's a strong electrostatic force between them, between the positive and negative, and they arrange themselves in solid form in a 3D lattice, something like what we've got shown here. Metallic bonding, the type of bonding we call it the metallic bond. The particles are the metal atoms. They're strong bonds, and they also arrange themselves in a 3D lattice. We're going to go into this in more detail later, so don't worry about the detail of it right now. But what you're looking at is a bunch of metal cations, so metals that have lost their valence electrons, metal atoms that have lost their valence electrons, surrounded by a sea of delocalized electrons, a bunch of electrons that are not attached to any particular atom and are free to move throughout the structure. And the force holding the whole thing together is the force between these positive and negative charges. Okay, the last type, not quite so common, but worth knowing about still, is what we call a covalent network. This happens in non-metals. A great example is diamond, which is made up purely of carbon atoms. The particles are atoms. In fact, let's go to a picture, and then we'll come back to explain how it works. So what we have here is an example of what diamond would look like if we could zoom right in. The spherical things are the carbon atoms. So these spheres are the carbon atoms. The purple lines are showing the covalent bond between carbon atoms. So there's a sharing of electrons between carbon atoms. So each carbon atom is bonded to 4 other carbon atoms in a covalent bond. You can think of it like a giant molecule, like one giant molecule where all these atoms are sharing electrons with the neighboring atoms. And that's a very strong intramolecular force. that holds the whole thing together, which is why diamond is extremely hard and has a very high melting point of about 4,000 degrees Celsius. It takes a lot of energy to overcome these bonds or to break them. So that's what we're talking about here. The covalent bond is strong within a larger network of covalent structures. Diamond is just one example. We have other types of covalent networks. We can have like a linear chain of atoms rather than the one that we just looked at in the picture was a 3D lattice. We can have also two-dimensional layers of covalent networks, which an example of that is graphite. But the most common one that you'll come across is this three-dimensional lattice, and examples of that are diamond or silicon dioxide. So that's the four bond types. Just to recap, we looked at covalent molecular, which are molecules. We've looked at ionic, we've looked at metallic, we've looked at covalent network, and we're going to look at all of these in more detail individually.